Now we are all set to start doing some AC circuit analysis. So recall what the impedance is for resistor, inductor, and capacitor. And if we have this circuit here where we have both A and B already in the phase domain, and then we have some resistors, capacitors, inductors, and we want to find the displacement current through that capacitor C1. Well, because we are in the phasor domain now, we can treat everything like a resistor. So what we can do, we can first group R1, R2, and C1, and just call that impedance 1, and that's going to be equal to 1 over 1 divided by R1, plus 1 divided by R2, plus j omega C1. Next, we can look at this inductor and capacitor, and just group those together as Z2. That's going to be equal to j omega L1 times 1 divided by j omega C2 divided by j omega L1 plus 1 divided by j omega C2. And lastly, we can group R3, L2, and R4 and just call that impedance 3, and that's going to be equal to 1 divided by 1 over R3 plus 1 divided by R4 plus 1 divided by j omega L2. And now what once appeared as a very difficult circuit, we can simplify greatly. And the reason that I represented all these impedances just by resistors, well, it's because you can treat them like resistors. Now we can look at the node Vx and simply say we have the phasor current going in and then coming out equal to Vx over Z1 plus Vx minus Vy over Z2. Or simply that Vx is equal to the phasor current plus Vy over Z2. And all of that is divided by 1 over Z1 plus 1 over Z2. Now, to solve for Vy, we simply say that going into that node, we have Vx minus Vy over Z2. It's going to be equal to Vy over Z3 plus the phasor current B, or simply that Vy is equal to Vx over Z2 minus phasor current B divided by 1 over Z2 plus 1 over Z3. And from finding this, we can plug this Vy right here, and then we're able to solve for Vx since we only have one variable. And because this node is Vx for all R1, R2, and C1, we can simply say that C1 is equal to Vx divided by 1 over j omega C1. And this will be our phasor current. Now we have to convert this back to the time domain. And that is the last step that we have. Now, this method seems very easy, but again, we do have all these complex numbers for Z1, Z2, and Z3. So the math does get a little bit messy, but it always gives you the exact result.